Now, in this lecture, we will find out the values of x and y. In the drawing, we have square DEFB that is inside the right triangle ABC. We know that the hypotenuse of the right triangle ABC is equal to 3 units, and one side of square DEBF is equal to 1 unit, that is to say DB equals to BF equals to 1 unit, and we want to find out the values of AD, that is Y, and the value of CF, that is X. So actually we know that the opposite sides of a square are parallel to each other. Therefore we know that DE is parallel to BF. I'll write it down. We know that side DE of square DFEB is parallel to side BF, because the opposite sides of a square are parallel to each other. So DE is parallel to BF, but PC is one side of the right triangle ABC, therefore it is absolutely a straight line, and BF is part of the straight line BC, and we know that DE is parallel to BF, therefore BC, that is a straight line, must be also parallel to DE, because if a line is parallel to other line, then if we know that BF is part of BC, that is a straight line, and it's parallel to DE, then BC must be also parallel to DE. Okay? Because if part of BC, that is a straight line, is parallel to DE, then the whole straight line BC will be also parallel to DE. Okay? So we can write down that BC is parallel to DE. I repeat again, part of the straight line BC, that is to say BF, is parallel to DE. So if part of a straight line is parallel to another straight line, then the whole straight line will be also parallel to that line. So BF, that is part of BC, is parallel to DE, therefore BC must be also parallel to DE, because the part of BC is parallel to DE, and BC is a straight line, therefore BC will be also parallel to DE. And we have the rule that corresponding angles between parallel lines are equal to each other. According to rule number 1, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. So I read rule number 1 again. Rule number 1 states that corresponding angles between parallel lines are equal to each other. Actually, DE is parallel to BC, and we have those two angles that are corresponding angles. Therefore, we will define if this angle is theta, then this angle will be also equal to theta because of the fact that those two angles are corresponding angles and they are located between the parallel lines DE and BC, therefore they are equal to each other. So if this angle is equal to theta, this angle will be also equal to theta. Okay? So in the next step, we will focus on the right triangle, triangle ADE. On the right triangle, triangle ADE. Actually, we know that triangle ADE is a right triangle because of the fact that AB is a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line AB, then the sum of the angles must be equal to 180 degrees. So if we define this angle as angle X, then we know that X plus 90 degrees, X plus 90 degrees must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. We will subtract 90 degrees from this equation and we will get that angle X equals to 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So we substitute angle X by a right angle. And actually, triangle ADE is a right triangle. Likewise, here we know that BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. And according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, then if you focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal to 180 degrees. So if this angle is X, then we will get that 90 degrees plus X must be equal to 180 degrees. According to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees, therefore the sum of the angles on the straight line, on the upper side of the straight line BC must be equal to 180 degrees at point F, that is to say angle X plus 90 degrees equals to 180 degrees. If we subtract 90 degrees from this equation, we will get that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X is equal to 90 degrees, that is to say it is a right angle. So we'll substitute angle X by a right angle. Therefore, actually, triangle EFC is a right triangle. And also triangle ADE is also a right triangle. So in the right triangle, triangle ADE, we know that tangent theta equals to AD over DE, AD over DE. By the way, we know that all the sides of a square are equal to each other, that is to say BF equals to 1 unit, therefore BD also equals to 1 unit, DE will be also equal to 1 unit, and FE will be also equal to 1 unit, as you already know. So in the right triangle ADE, we know that tangent theta equals to AD over DE. Okay, in the right triangle ADE, we know that tangent theta equals to AD over DE. But AD equals to y. It is given us in the question. DE, we already found out that DE equals to 1 unit because it is one side of a square. We know that all the sides of a square are equal to each other. So we actually found out that according to equation number 1, tangent theta equals to y. Tangent theta equals to y. According to equation number 1, tangent theta equals to y. In the next step, we will focus on the right triangle EFC. On the right triangle EFC, we know that tangent theta equals to EF over FC. I'll repeat again. On the right triangle EFC, we know that tangent theta equals to EF over FC. But EF equals to 1, because it is one side of square BFED. EF equals to 1, and FC equals to x. So in conclusion, we found out that according to equation number 2, tangent theta equals to 1 over x. I'll repeat again. We found out that according to equation number 2, tangent theta equals to 1 over 2, to 1 over x. So we'll create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Okay, equation number 3 states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. That is to say, we found out that tangent theta according to equation number 1 is y, and it must be equal to tangent theta according to equation number 2, that is actually 1 over x. So we found out that y equals to 1 over x. If we multiply this equation by x, we'll find out that x times y equals to 1, and when the multiplication of two numbers is equals to 1, it means that one number is the inverse number of the other. So if, for example, x equals to 5, then y must be equal to 1 over 5. So x and y are two inverse numbers. X is inverse to y, and y is the inverse number of x. Okay? If x equals to 2, then y must be equal to 1 over 2, because their multiplication 2 times 1 over 2 must be equal to 1. So 2 times 1 over 2 is 1. Okay? So we know that x and y are two inverse numbers. Okay? One is inverse to the other one. X inverse is the inverse number of y, and y is the inverse number of x. Okay, in the next step we will focus on the right triangle ABC. On the right triangle ABC, according to the Pythagoras theorem, here the letters PT is the abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So equation number 4 will be that AB squared plus BC squared must be equal to the square of the hypotenuse, that is actually AC squared. I repeat again, in the right triangle ABC, according to equation number 4, we will get that AB squared plus BC squared equals to AC squared. AB equals to y plus 1. So AB squared will be equal to y plus 1 squared plus BC squared. BC is equal to 1 plus x, therefore BC squared will be equal to 1 plus x squared, or x plus 1 squared, and it equals to AC squared. It is given us in the question that the hypotenuse AC of the right triangle ABC equals to 3 units. So AC squared is 3 squared. 3 squared is 9. So in conclusion, we found out that according to equation number 4, y plus 1 squared equals y plus 1 squared plus x plus 1 squared equals to 9. Here we will open the brackets of those two expressions, and we will get that according to equation number 4, y plus 1 squared is y squared plus 1 plus 2y, and x plus 1 squared is x squared plus 1 plus 2x, that equals to 9. According to equation number 3, y equals to 1 over x. So we'll substitute y in equation number 4 by 1 plus x, and we will get that y squared will be equal to 1 over x squared plus 1 plus 2y is 2 times 1 over x plus x squared plus 1 plus 2x equals to 9. So here we can organize the equation in such a way that here we'll have 1 over x squared, or x squared plus 1 over x squared plus 1 plus 1 is 2 Okay. Plus 2x plus 2 over x, that equals to 9. X squared plus 1 over x squared plus 2 is x plus 1 over x squared. So I will write it down. X plus 1 over x squared plus, here we take 2 as a common factor of these two expressions. Inside the brackets we will have 1 plus 1 over x. Here we subtract 9 from this equation and we get that, actually we found out that x plus 1 over x squared plus 2 times 1 over plus 2 times 1 plus 1 over x minus 9 equals to 0. Here we will define t will be equal to x plus 1 over x, and therefore we get here a quadratic equation that states that t squared plus 2 times t minus 9 equals to 0. Okay, and the general solution, actually the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b and c are the coefficients of the quadratic equation and x is the variable that we are looking for. In our specific equation, t is the variable that we are looking for, and the solution of a quadratic equation, in this general quadratic equation, the solution is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a in our specific quadratic equation. The variable that we are looking for is t, so x equals to t, and we also know that the coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 9. So we will put the data inside the general formula for the general solution for x. In our specific expression, the variable x is actually the variable that we are looking for is t, so x equals to t, that equals to minus b, so b is 2, so minus b is minus 2, plus minus square root of b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, and c is minus 9, so minus 4 times minus 9 is plus 36 over 2a. A is 1, so it is over 2. So in conclusion, we found out that the value of t that equals to 1 plus 1 over x is equals to minus t plus minus square root of 4 plus 36 over 2. So here 4 plus 36 is 40. So I write it down. So we got that t equals to minus 2 plus minus square root of 40 over 2. 40 is actually 4 times 10, and the square root of 4 is 2. So in conclusion we get that t equals to minus 2 plus minus 2 times square root of 10 over 2. Here 2 over 2 is minus 1, and minus 2 over 2 is minus 1, and 2 over 2 is 1. So in conclusion we get that t equals to minus 1 plus minus square root of 10. So we actually found out that t equals to minus 1 plus minus square root of 10. So we have two possible solutions for t. We will write down both of those two solutions. The first solution is t equals to minus 1 plus square root of 10, and the second solution for t is t equals to minus 1 minus square root of 10. We know that t is equal to x plus 1 over x, and as you already know, x is the length of one side of the triangle, or part of a triangle, so it must be a positive number. While here we got t that equals to minus 1 minus square root of 10. So t that equals to x plus 1 over x, that must be a positive number, cannot be equal to minus 1 minus square root of 10, that is a negative number. It must be a positive. So this solution is incorrect solution, so this solution is not possible, and we left only with the solution that t equals to minus 1 plus square root of 10. That is to say, the positive root of 10. So t that equals to x plus 1 over x equals to minus 1 plus the positive square root of 10. Here we will multiply x by x, and then we will divide it by x, and we will get that x squared plus 1 over x equals to square root of 10 minus 1. So here we will multiply this equation by x. You know that x can never be 0 because it is the length of a side of a triangle. Therefore it can never be 0, it must be a positive number. Okay, so we can multiply the equation by x, and we'll get that x squared it is actually plus 1 x squared. It is actually plus 1 x squared plus 1. So it is x squared plus 1 equals to square root of 10 minus 1 times x. Here we will subtract from this equation square root of 3 minus 1 times x, and we will get that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So here we got a quadratic equation. A equals to 1, B equals to minus square root of 10 minus 1, and C equals to 1. And the solution to the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So here we put the data inside and the formula for x, and we'll get that x equals to minus b, b equals to minus square root of 10 minus 1, so it is minus square root of 10 minus 1 plus minus square root of b squared is actually square root of 10 minus 1 squared minus 4 times a is 1 times c is 1. So it is actually minus 4 over 2a. 2a is 1, so 2 times 1 is 2. So here minus and minus is plus, so it's here it will become plus, and inside the root, so we got that x equals to square root of 10 minus 1 plus minus square root of here square root of 10 minus 1 square will be equal to 10 plus 1 minus 2 times square root of 10 times 1 minus 4 over 2. So x equals to square root of 10 minus 1 plus minus here we have actually 10, it is actually here plus 1. 10 plus 1 is 11, 11 minus 4 is 7. So it is actually 7 minus 2 times square root of 10 over 2. So you got this expression. So what is the value of 7 minus 2 times square root of 10? 7 is 5 plus 2. So I write it down. 7 equals to 5 plus 2 minus 2 times square root of 10. And 5 equals to square root of 5 square. 2 equals to square root of 2 square. Minus 2 times square root of 10 is square root of 2 times square root of 5. So it is actually equal to 5 minus square root of 2 square. 5, or actually square root of 5 minus square root of 2 square. Okay, so we found out that 7 minus 10 times square root of 7 minus 2 times square root of 10, it is actually equals to square root of 5 minus square root of 2 square. Why? Because square root a minus b square equals to a square plus b square minus 2 times ab. It is exactly this expression. So here we substitute 7 minus 2 times square root of 10 by this expression, and we get that x equals to square root of 10 minus 1 plus minus. So we substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square over over 2. So here the square cancels the root. The square cancels the root, and we left only with square root of 5 minus square root of 2. So in conclusion, we got that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 over 2. So we will have here two possible solutions. So here I must repeat on it in order to verify that there is no mistake. So here we have two solutions that are possible. The first solution will be x equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. And the second possible solution will be x equals to square root of 10 minus 1 minus square root of 5 plus square root of 2 . So we start with the first solution. The first solution, x equals to 10 is square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2. So here we take square root of 5 as a common factor. X equals to square root of 5. Here we have square root of 2 plus 1 minus square root of 2 plus 1 . So here we take square root of 2 plus 1 as a common factor out of these expressions, and we get that x equals to square root of 2 plus 1, and inside the bracket we will have square root of 5 minus 1, all divided by 2, of course. So the first solution is x equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. And the second possible solution will be x equals to 10 is 2 times square root of 2 times square root of 5 minus square root of 5 plus square root of 2 minus 1. Here we take square root of 5 as a common factor, and inside the brackets we'll have square root of 2 minus 1, and here we will have plus square root of 2 minus 1. So here we take square root of 2 plus minus 1 as a common factor, and we get that square root of 2 minus 1. Here we will have square root of 5 plus 1 over 2, of course, all divided by 2. So the second solution is that x equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. Here we'll multiply x by x, and we'll get that x times x, here we have a plus b minus b, that is a squared minus b squared. That is to say, it will be equal to 2 minus 1, and here square root of 5 minus 1 times square root of 5 plus 1 is equals to a squared a plus b times a minus b equals to a squared minus b squared, that is to say, it will be equal to 5 minus 1 over 2 times 2, that is 4. So here we have 1 times 4 over 4 is 1. So we actually found out that the two solutions, the multiplication of the two solutions of the quadratic equation is equals to 1. It means that the two solutions for x are two inverse numbers. One solution is the inverse number of the other solution, but according to what we have already found out, that according to equation number 3, x times y equals to 1. That is to say, x and y are also two inverse numbers. One number is the inverse number of the other number, so we get that the two solutions that are possible for x and y are, the first solution is x and y. The first solution will be square root of 2 plus 1 times square root of 5 minus 1 over 2. That is x, and y is the inverse number. That is to say, it will be equal to square root of 2 minus 1 times square root of 5 plus 1 over 2. So this is the first pair of solutions for x and y, and the second pair of solutions for x and y. The second solution for x, it is actually equals to square root of 2 minus 1 over square root of 5 plus 1 over 2. That is x, and y is the inverse numbers of x, because x times y is equal to 1 according to equation number 3. So the value of y will be equal to square root of 2 plus 1 times square root of 3 minus 1 over 2. Okay, actually that is the two pairs of solutions for x and y, and that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the value of x and y in this drawing. We have a square DEBF that is inside the right triangle ABC. We know that one side of this square is equals to 1 unit, DB equals to BF equals to 1 unit, and we also know that the hypotenuse of the right triangle ABC equals to 3 units, and we want to find out the value of FC, that is x, and the value of AD, that is y. So first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF, the opposite sides of a square are parallel to each other, that is to say DE is parallel to BF. But BF is part of BC, that is a straight line. So if DE is parallel to the part of the straight line BC, it must be also parallel to BC itself. Because when you have a line that is parallel to a part of a straight line, it must be parallel to the whole straight line also. So DE is parallel to part of the straight line BC, therefore DE also must be parallel to the straight line BC, because BC is one straight line. So if DE is parallel to the part of the straight line BC, it must be also parallel to the whole straight line BC. So DE also must be parallel to BC. BC is parallel to DE, and we have rule number 1 that states that corresponding angles between parallel lines are equal to each other. So we have those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC, therefore they are equal to each other. Okay? So if this angle equals to theta, then this angle must be also equal to theta. Okay? And here, triangle ADE is a right triangle because of the fact that angle ADE is a right angle. Why angle ADE is a right angle? Because of the fact that AB is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. AB is a straight line. And we know that the sum of the angles on one side of a straight line are equal to 180 degrees. So if we focus on this side of the straight line BE, then the sum of the angles must be equal to 180 degrees at point D. So which angles we have at point D? On the straight line AB, we have here 90 degrees plus this angle that is angle Y. The sum of those two angles must be equal to 180 degrees according to the rule that I stated. So here, we define this angle as angle X, so angle X plus 90 degrees must be equal to 180 degrees. Okay? According to the rule that the sum of the angles on one side of a straight line are equal to 180 degrees. So if we subtract 90 degrees from this equation, we will get that angle X equals to 90 degrees. So this angle is equal to 90 degrees, therefore triangle ADE is a right triangle. Okay? And likewise, BC is one side of the right triangle ABC. Therefore, it is absolutely a straight line. And we know we have the rule that the sum of the angles on one side of a straight line must be equal to 180 degrees. So if we focus on the upper side of the straight line BC at point F, the sum of the angles must be equal to 180 degrees. So this angle that equals to 90 degrees plus this angle that is angle X must be equal, the sum of the two angles must be equal to 180 degrees. So X plus 90 degrees equals to 180 degrees. So if we subtract 90 degrees from the equation, we will get that this angle equals to 90 degrees. Therefore, triangle EFC also is a right triangle. So we found out that those two triangles, triangle ADE and triangle EFC, are both right triangles. So in the right triangle, triangle ADE, we know that tangent theta equals to AD over DE. Okay, in the right triangle ADE, we know that tangent theta equals to AD over DE, but AD equals to y according to what is given us in the question. D equals to 1 because it is a square and all the sides of the square are equal to each other, and one side is equal to 1, so all the other sides are also equal to 1 unit, so DE also equals to 1 unit. So we found out that AD equals to y over 1, and the tangent theta equals to y over 1, that is to say tangent theta equals to y, according to equation number 1. Then in the right triangle, triangle EFC, we know that tangent theta equals to EF over FC. Tangent theta equals to EF over FC, but EF equals to 1, FC equals to x, according to what is given us in the question. So in conclusion, we found out that according to equation number 2 in the right triangle EFC, tangent theta equals to 1 over x. So according to equation number 2, tangent theta equals to 1 over x. And according to equation number 1, tangent theta equals to 1. Tangent theta equals to y. So we will create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. So tangent theta according to equation number 1 is y, and tangent theta according to equation number 2 is 1 over x. So in conclusion, according to equation number 3, y equals to 1 over x. And if we multiply equation number 3 by x, we get that x times y equals to x, that is to say, x and y are two inverse numbers. Okay? For example, if x equals to 5, then y must be equal to 1 over 5 because the multiplication of those two numbers are equal to 1, so they are two inverse numbers to each other. Okay. Then we focused on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BC square equals to AC square. In the right triangle, triangle ABC, according to the Pythagoras theorem, AB square plus BC square equals to AC square. AB equals to y plus 1, so AB square is y plus 1 square, and BC equals to x plus 1, so BC square equals to x plus 1 square, and they are equal to the square of the hypotenuse, that is to say they equals to AC square, that is 3 square. 3 square is 9, so here we open the brackets of those two expressions, and we found out that y plus 1 equals to y square plus 1 plus 2y, and x plus 1 square equals to x square plus 1 plus 2x, that equals to 9. So according to equation number 3, y equals to 1 over x, so we can substitute y by 1 over x. We did it, and we got that according to equation number 4, y square is 1 over x square plus 1 plus 2y is 2 times 1 over x plus x square plus 1 plus 2x equals to 9. Then we organize the numbers here, the variables. Here we have x squared plus 1 over x squared plus 2, because 1 plus 1 is 2, plus 2 over x equals to 9. So here this expression x squared plus 1 over x squared plus 2 is equal to x plus 1 over x squared. And here we took 2 as a common factor. So we got that x plus 1 over x squared, that is actually equals to x squared plus 1 over x squared plus 2, Here we took 2 as a common factor, so inside the brackets we will have 1 plus 1 over x minus 9 equals to 0. Then we defined t that it will be equal to x plus 1 over x according to our definition. So therefore equation number 4 will be t squared plus 2t minus 9 equals to 1. So here we have quadratic equation. The general formula for a quadratic equation is t squared plus 2t minus 9 equals to 0. And this is our specific quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we find out the value of x according to the special formula that x equals to minus b plus minus square root of b squared minus 4ac over 2a. In our specific expression, the variable that we are looking for is t, so x equals to t, and here a equals to 1, b equals to 2, and c equals to minus 9. Here you can see the coefficients of our specific quadratic equation: a equals to 1, b equals to 2, and c equals to minus 9. So we will put the data inside the equation for x, and we will find out that t equals to x, so t equals to minus b, b is 2, so minus b is minus 2, plus minus square root of b squared is 2 squared, 2 squared is 4, minus 4 times a times c. So minus 4 times a is 1, c is minus 9, so minus 4 times minus 9 is 36, over 2a, 2 is 1, so 2 times 1 is 2. So t equals to minus 3 plus minus 4 plus 36 is 40, or over 2. 40 is 4 times 10, and the square root of 4 is 2, so in conclusion we got that 2 equals to t equals to minus 2 plus minus 2 times square root of 10 over 2. Here we divided the equation by 2, and we got that t equals to minus 1 plus minus square root of 10. But t, according to our definition, so we have two solutions that are possible for t, but t, according to our definition, is x plus 1 over x, and it equals to minus 1 plus square root of 2. Here we multiplied x by x, and then we divided by x, and we got that x squared plus 1 over x equals to square root of 10 minus 1. Here we multiplied this equation by x, and we got that x squared plus 1 equals to x times square root of 10 minus 1. Then we subtracted square root of 10 minus 1 times x from this equation, and we got that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. Here we got a quadratic equation. In this quadratic equation, the coefficients are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the solutions for this quadratic equation will be x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So x equals to minus b, b equals to minus square root of 10 minus 1. So minus b will be equal to minus minus square root of 10 minus 1. So minus is plus. So the sign will become plus. Plus minus square root of b squared. B is square root of 10 minus 1. So b squared will be equal to square root of 10 minus 1 squared. Minus 4 times AC is minus 4, because A equals to 1 and C equals also to 1. All divided by 2, so X equals to square root of 10 minus 1 plus minus, here we have square root of 2 minus 1 square, and we have also it is actually square root of 10 minus 1 plus square root of 10 minus 1 square is square root of 10 squared, that is 10, plus 1 squared, that is 1, minus 2 times 10 times square root of 10 times 1. So here we got that x equals to square root of 10 minus 1 plus minus, here we have 10 plus 1 is 11, 11 minus 4 is 7, and we have also minus 2 times square root of 10. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus square root of 7 minus 2 times square root of 10 over 2. So x equals to, and we know that 7 minus square root of 7 minus 2 times square root of 2 times square root of 10 equals to 7 is 5 plus 2 minus 2 times square root of 2, and 5 is square root of 5 square, 2 is square root of 2 square, minus 2 times square root of 10 is square root of 2 times square root of 5. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 square. So we can substitute this expression by square root of 5 minus square root of 2 square. We did it, and we got that x equals to square root of 1 minus 1, square root of 10 minus 1 plus minus square root of 5 minus 10 square over 2. Here we have square and root, the square cancels the root, and we got that x equals to square root of 2 minus 1 plus minus square root of 5 minus square root of 2 over 2. And then, so we have two solutions possible. X equals to either square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2, and the second solution that is possible, that x equals to square root of 10 minus 1 minus square root of 5 minus 2, and according to the third solution, we get that x equals to square root of 10 minus 1 plus square root of 5 minus 2 over 2. Here we substitute the square root of 10 by square root of 5 times square root of 2, and we got the square root of 5 times square root of 2 minus 5 plus square root of 5 minus square root of 2 over 2. So here we took a common factor of square root of 5, and inside the brackets we add square root of 2 plus 1 minus square root of 2 plus 1. Here we took square root of 2 plus 1 as a common factor, and in conclusion we got that x equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. We did the same process for the second solution, and we got that in the second solution that x equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. Then we multiplied the first solution for x by the second solution for x for the quadratic equation, and we found out that x1 times x2 is equals to 1. That is to say that the two numbers are inverse numbers to each other, and therefore we found out that x equals to either square root of 2 plus 1 times square root of 5 minus 1 over 2, that is x, and the opposite, the inverse numbers of x, that is actually y, will be equal to square root of 2 minus 1 times square root of 5 plus 1 over 2. This is the first solution, and the second solution is that x equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. That is x, and y equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay, those are the two solutions that are possible for x and y. And that is actually the answer to the questions. We have two solutions for x and y. This is the first solution, and this is the second solution. And we know that x and y are two inverse numbers. When you multiply two inverse numbers by each other, you will get 1. And according to equation number 3, x times y equals to 1. That is to say, there are two inverse numbers to each other, and those are the solutions for x and y. So those are the two solutions for x and y. And okay, that's all.